For this next problem, we're going to create a function to solve an applied word problem, and then we'll evaluate the function we create at a given value. We've got a community skating rink that's in the shape of a rectangle with semicircles at the ends. The length of the rectangle is 20 feet less than twice the width, and the thickness of the ice is 0.75 inches. For this situation, we want to write the ice volume V as a function of the width x. And then for part B, we want to figure out how much ice is in the rink if the width is 90 feet. First thing we should do is define some variables. We've said that x is the width of the ice rink, so we have this rectangle part in the middle. We want to define the length, and in the problem we've told that the length is 20 feet less than twice the width. Twice the width is 2x, less 20 is minus 20, so we'll have the length is 2x minus 20. That way we have expressed it in terms of the width x. The radius of the semicircle is half of the width. Since we said the width is x, the radius will be x over 2. To get the volume of the ice, we want to start by finding the surface area of the ice. If we consider these are the two semicircles, we could put them together to form a complete circle. So we really have a rectangle and a circle that we need the area for. So the total surface area is going to be the area of the rectangle, which we'll write as length times width, plus the area of the circle we get by combining the ends, which will be pi times the radius squared. Now we need to have all of this in terms of the width x, so we need to put in what we've set up here for our variables. The length is 2x minus 20, so we'll write 2x minus 20. The width we said was x, plus pi times, now the radius we said was x over 2, so we have x over 2 squared. We want to clean this up a little bit. So we'll have 2x squared minus 20x plus pi x squared over 4. And so we have this expression for the surface area in terms of x, but we want the volume. And we know that the thickness of the ice is 0.75 inches. Everything else we've done up here has been in feet, and here we have inches, so we need to make sure that we write this in terms of feet. And 0.75 inches turns out to be 1/16 of a foot. So we have all the same units here. To get the volume, we just need to multiply the area by the thickness. So the area times 1/16, we'll have 2x squared minus 20x plus pi x squared over 4, all of that times 1/16. Now that we've written an expression for our volume, we want to write it in function notation since the problem asks us to write a function. Here's our expression. In function notation, we're going to write v of x, so we see that the volume is a function of x. We multiply these two together, our volume will be x squared over 8 minus 5x over 4 plus pi x squared over 64. And so here we have the volume expressed as a function of x alone. In part B, we're asked to find the volume of the ice if the width is 90 feet. So we're actually given that x is equal to 90 feet. So we just need to evaluate v of 90. We let x equal 90 in our definition. We'll have 90 squared over 8 minus 5 times 90 over 4 plus pi times 90 squared over 64. And if we evaluate that, we get that the volume is roughly 1,297.61 cubic feet.